The United States Navy is about to unleash something that will redefine power projection across the globe. We're talking about a $120 billion investment that's creating the most advanced naval force in human history. The Ford-class aircraft carrier program represents the largest single military investment since the Manhattan Project, and what they're building will change everything you thought you knew about naval warfare. Right now, in shipyards across America, engineers are constructing floating cities that dwarf anything ever built. The Gerald R. Ford, already commissioned, stretches 1,106 feet long and displaces over 100,000 tons when fully loaded. To put that in perspective, you could park the Empire State Building on its side and still have room left over. But size alone doesn't justify a $120 billion price tag. What makes this investment revolutionary is the technology packed into these vessels. Each Ford-class carrier represents a complete reimagining of naval aviation, incorporating systems that didn't exist when the previous Nimitz-class was designed in the 1960s. The Navy plans to build 10 of these maritime behemoths, with each ship expected to serve for 50 years. That means the technology being installed today needs to handle threats we haven't even imagined yet. The engineers aren't just building for today's conflicts, they're preparing for the wars of 2080. For decades, aircraft carriers used steam catapults to launch planes, technology that hadn't fundamentally changed since World War II. The Ford class throws that playbook out the window with something called the Electromagnetic Aircraft Launch System, or EMALS. This system generates 13,800 kilovolts of electrical power to create magnetic fields powerful enough to accelerate a 30-ton fighter jet from 0 to 150 miles per hour in under 3 seconds. The precision is incredible. Computer systems adjust the launch power in real time based on the aircraft's weight, weather conditions, and mission requirements. Chief Petty Officer Jeremy Sline, who's worked on both old and new systems, puts it simply: with steam catapults, you got what you got. With EMALS, we can launch everything from massive cargo planes to lightweight drones with the same system. The implications are staggering. Previous carriers could launch about 120 sorties per day. The Ford class can push out over 200 missions daily, a 67% increase in combat capability. When you're projecting power halfway around the world, that difference can determine the outcome of entire conflicts. Beneath the flight deck lies the real game changer: 2 A-1B nuclear reactors that produce 3 times more electrical power than any previous carrier. We're talking about enough electricity to power a city of 100,000 people, all contained within the hull of a single ship. Let's talk about propulsion. The Ford class is essentially an electric ship. Everything from the catapults to the elevators to the defensive systems runs on electrical power. The reactors can operate for 25 years without refueling, meaning these carriers can stay deployed indefinitely without the vulnerability of fuel supply lines. Compare that to diesel-powered vessels that need refueling every few weeks, creating logistical nightmares and tactical vulnerabilities. Admiral Mike Butler, who oversees Ford-class construction, explains, "When you can stay on station for months without resupply, you fundamentally change the strategic equation. Enemies can't wait you out." The electrical systems alone required over 3 million meters of cabling, enough to stretch from New York to Los Angeles. Every system is redundant, every component is hardened against electromagnetic pulses, and the entire network can be reconfigured in real time to handle battle damage. Getting aircraft off the deck is only half the battle. Bringing them back safely requires technology that borders on science fiction. The Ford class uses an advanced arresting gear system that can stop a 50,000-pound fighter jet traveling at 150 miles per hour in just 320 feet. The system uses water twisters, massive paddle wheels submerged in fluid that create precisely controlled resistance. Computer systems monitor the landing aircraft's weight, speed, and approach angle, adjusting the arresting force hundreds of times per second to prevent overstressing the airframe. Lieutenant Leslie Garcia, a Navy pilot with over 1,000 carrier landings, describes the difference. On older carriers, every landing felt like controlled violence. The Ford-class system is so smooth you barely feel the deceleration. That means less stress on aircraft, fewer maintenance issues, and more missions. The precision is remarkable. The system can handle aircraft ranging from 10,000-pound drones to massive 80,000-pound cargo planes, automatically adjusting for each landing. Previous arresting systems were essentially one-size-fits-all, leading to frequent aircraft damage and maintenance delays. Here's where things get really interesting. The massive electrical generation capacity of the Ford class enables weapons systems that were pure science fiction just decades ago. While specific details remain classified, the Navy has confirmed these carriers can power directed energy weapons, essentially laser systems capable of destroying incoming missiles and aircraft. The electrical infrastructure also supports advanced radar and electronic warfare systems that can jam enemy communications across hundreds of miles. Former Navy engineer Marco Estrada hints at the capabilities. When you have that much clean electrical power available, you can do things that smaller ships simply cannot. The electromagnetic spectrum becomes your battlefield. These systems represent a fundamental shift in naval warfare. Instead of relying purely on kinetic weapons, missiles and bullets, the Ford class can engage enemies using energy weapons that travel at the speed of light and have virtually unlimited ammunition as long as the reactors are running. The $120 billion investment in Ford-class carriers represents more than just military hardware. It's a statement about American intentions for the next half-century. Each carrier battle group can project more firepower than most entire national militaries, and they can do it anywhere in the world. China's rapid naval expansion has created the first peer-level naval competition America has faced since the Cold War. The Ford-class program is America's answer, providing capabilities that will be extremely difficult for potential adversaries to match. Building nuclear-powered supercarriers requires industrial capabilities that only a handful of nations possess. The economic implications are equally significant. Each Ford-class carrier supports approximately 75,000 jobs across the American defense industrial base. The program has driven innovations in metallurgy, electronics, nuclear engineering, and advanced manufacturing that benefit civilian industries as well. Building these floating cities requires engineering solutions that push the boundaries of what's possible. At Newport News Shipbuilding, the world's largest crane, nicknamed Big Blue, can lift 1,050-ton ship sections with precision measured in inches. The construction process uses modular superlifts, massive pre-built sections that are assembled like enormous building blocks. The lower bow section alone stands 60 feet tall and stretches over 100 feet long, containing 7 smaller units welded together into a single piece. Jeff Hamel, who supervises construction of the John F. Kennedy, the second Ford-class carrier, describes the complexity. We're essentially building a small city that has to survive in the most hostile environment on Earth, the open ocean during wartime. Every system has to work perfectly every time for 50 years. The welding alone requires over 1.8 million kilograms of steel, joined by welders who undergo years of specialized training. The tolerances are so tight that sections built months apart must align within millimeters when finally assembled. The Ford-class program represents America's bet on how naval warfare will evolve over the next 5 decades. The massive electrical generation capacity suggests the Navy expects energy weapons to become primary armaments. The advanced automation systems indicate future operations with smaller crews and greater reliance on artificial intelligence. The modular design philosophy means these carriers can be upgraded with technologies that don't exist yet. The electrical and data infrastructure can support systems that today's engineers can only imagine. As threats evolve, the Ford class can evolve with them. Perhaps most significantly, the program demonstrates American commitment to maintaining naval supremacy regardless of cost. At $120 billion for 10 ships, this represents one of the largest peacetime military investments in history. The message to potential adversaries is clear. America intends to dominate the world's oceans for the next half-century. Behind all this advanced technology are the 4,500 sailors who will call each Ford-class carrier home during deployments that can last 8 months or longer. These floating cities include everything from post offices to coffee shops, gyms to medical facilities capable of performing major surgery. The crew represents the ultimate fusion of human skill and advanced technology. Petty Officer Daniel Rivera, who participated in the initial EMALS testing, captures the experience. You're launching aircraft worth more than most people's houses, using technology that feels like magic, but at the end of the day, it comes down to training, teamwork, and trusting the person next to you. The Ford class requires fewer crew members than previous carriers, despite being larger and more capable. Advanced automation handles many tasks that previously required human operators, but the remaining crew must be more highly trained than ever before. America's $120 billion investment in the Ford-class aircraft carrier program represents the largest single military modernization effort since World War II. These floating fortresses will define naval warfare for the next half-century, projecting American power across the globe with capabilities that seemed impossible just decades ago. From electromagnetic launch systems that can fire aircraft into the sky with computer precision, to nuclear reactors that provide unlimited range and unprecedented electrical power, to recovery systems that can safely land aircraft in conditions that would have been impossible for previous generations. The Ford class represents a quantum leap in military capability. The program demonstrates America's commitment to maintaining naval supremacy in an increasingly competitive world. As potential adversaries develop their own advanced naval capabilities, the Ford class ensures American forces will maintain the technological edge necessary to protect national interests and allied nations worldwide. But what do you think about America's massive investment in naval supremacy? Are these floating fortresses the key to maintaining peace through strength, or do they represent an escalation that could spark a new arms race? Drop your thoughts in the comments below, and don't forget to subscribe for more deep dives into the military technology shaping our world.